Two equal chords AB and CD of a circle, when produced, intersects at the point P. Prove that PB is equal to PD. Okay, so we have two equal chords. Oh yeah, you guys have to figure out what is the diagram before I put it on the screen. It's better that you guys do it on your own. Okay, what is that? We have two equal chords, right? And we need to extend them. So I'm doing it at one go. So something like this, and yeah, this is how it is going to look for me. So what is given over here? We have the following. We have point A, point B, point P, and point Q. So AB is equal to this length is equal to this length. And they have extended, and it apparently meets, no, they're given the names actually, two chords AB and CD. When produce intersects at P. So this is D and that's A actually. So we have AB and we have this to be CD. They're meeting at P. I think other way around also we can prove it, but yeah, I'll just take it to be this in this order. When produce at a point P, right, we have that. Prove that we have the length, entire length is equal to this entire length. How will we do it? So this, by the way, is, I'll increase it to level 2 plus, not level 2, it's level 2 plus clearly. So we don't have any construction as of now. I didn't tell any, but now I'll tell. This is your clue as well. I'm dropping a perpendicular line, say O, this is say T and OM. And also I'll join, okay, I won't tell the next clue. So these are your perpendicular lines. A bit of construction. That is, we are joining. Not join, sorry. Draw OT perpendicular to AB and OM perpendicular to DC. Okay, what next? Yes, next clue is join OP. Right, yes. So this is our line OP. So that's your clue. So now you guys figure out, it's quite simple. Yes, it is to do with similarity. Or sorry, similarity, congruency. Similarity comes in the other grade. So which two triangles? Clearly these two triangles. Okay. So how do you prove that these are congruent? Quite simple. The writing is a bit lengthy though, but the concept is simple. To prove, actually, first we need to write to prove. We have to prove that PB is equal to PD. Then we have the proof. Consider, no. First thing is we'll talk about how will we prove it. First of all, let's discuss that. How will we prove this? OP is common, that is there. We have right angle, that is also correct. And what else? Yes, OT is equal to OM, right? So I think, yeah, that's enough, is it not? So we have one common, one angle and one side, but this is side angle. It doesn't work out, is it not? No, it works out because it is right angle, hypotenuse and a side, RHS. We can use that. So we'll start off with the following. In triangle OTP and triangle OMP. So what do we have? We have the length OP as a common side. Then we have, what else we have? Angle OTP is equal to angle OMP. Both are equal to 90°. Reason being, we'll just write it off. OT is perpendicular to AB and OM is perpendicular to DC. And then we have one more thing. What is it? Yes, OT is equal to OM. But why is it so? How is that I'm able to tell this? What theorem am I using over here? Yes, equal chords of a circle are equidistant from the center. Okay, equal chords, because equal chords of a circle are equidistant from the center, right? So with all of this, what can we conclude? We already discussed this. Therefore, triangle OTP is congruent to triangle OMP. The order should be always correct. This is because of what congruency? RHS congruency. Using this, we'll be able to prove it. Now, with all of this, what is the point of doing this? Yes, we'll be able to tell that PT is equal to PM. But that's not the answer. We need to prove that PB is equal to PD. How will we do it? Therefore, by CPCT, I happen to prove that PT is equal to PM. But what next? How will we go about doing this? The next clue is this. I have AB, which is equal to DC. Okay, that's your clue. Yes, when we divide this with 2, what do we have? AB by 2 is equal to AT and TP. I'll just write TB. And then we have DC by 2 is DM. DC by 2 is DM. But why is it so? Because of, which theorem are we looking at? Perpendicular drawn from the center of the circle to a chord bisects the chord. Perpendicular from the center to a chord bisects them. And with this reasoning, what can we conclude? That TB is equal to DM. Is it not? So therefore, TB is equal to DM. But how can I use this? How can we use this? I'll call this as 1 and this as 2. Yes, we need to add 1 and 2. Right? So we have TM plus TB is equal to PM plus MD. So clearly all of this is equal to PB and this is equal to PD. And we have the answer. Okay, yes, that's it. So you can pause and have a look at the answer.